because of that accumulation thing, carbon gets stuck to all sorts of stuff that goes into our cells. Anything that methylates is absorbed. All you need for something to accumulate is that your body thinks it's useful. And there's a few other things, but carbon's the big one. When we methylate any random elements, our cells will absorb it. Then, as soon as our cells have absorbed it, well, nothing can digest these methylated compounds, and so they're just all over our food web. They're just stuck to random carbons. And so they're all magnifying through all these layers of the food chain. And because we are lucky enough to graze on predators from all over the ocean, we're the end of that funnel. That's our diet. Yesterday, I spent one whole period talking about bioaccumulation and biomagnification, just so that I could talk today about the nonsensical, whimsical chaos of our atmosphere and our dietary funnel. But I'm ready to move on unless you wanted to ask me something. I'm available for questions on bioaccumulation and biomagnification. Yeah?
Is there a way that the carbon would bond with another hydrogen and like...
Yeah, most of it does. And
no,
so,
and like get rid of like the other one?
So you mean to say, do methyl groups ever just make methane?
No, like...
Does hydrogen tear these apart?
Yeah. Like is there a way to like shoot hydrogen out?
Yeah, I mean, hydrogen's almost never found on its own. Hydrogen is a diatomic gas, Hofbrinkel, and so hydrogen doesn't really exist for very significant moments. And so if you could get like a hydrogen gun, maybe, I don't know, it depends on what your bond strength is. So I think hydrogen makes a stronger bond than most other elements to I think methyl groups have a preference for hydrogen, so I think that they would, but I don't know how viable that is. By the way, you can settle this without me, just figure out the bond strength of hydrogen versus other elements, and you can figure out which ones would break these and which ones would not. Yeah?
Is there kind of just like a short way to like sum up like the main, sorry, the main like difference between the two? Because sometimes I still get them like confused.
Absolutely. You can all write this in your notes right now. Bioaccumulation is a cellular process. Biomagnification is a food web process, food chain process, trophic process. One is cellular, one is trophic. Okay. Anybody else want to ask me anything about bioaccumulation, biomagnification? Otherwise, I'm going to skip. We have like 3 more study goals to wrap up 5.2. So. Okay. Let's finish that assignment. You guys want to know something funny? When I say how much coal we burn, your brain goes, yes, that's a lot. But your brain can't contextualize what that means. Like when I said 7.7 billion tons versus 14 trillion pounds, that's the same number, but for your brain it's all just like, that's a lot. And you can't really think of big numbers.
I have a good way to like think of billion versus trillion, or like million versus billion.
More zeros?
No.
Yeah.
A million is about, like a million seconds is about 10 days, but a billion seconds is about 30 years.
Yes, tens of thousands. Yes, I can do that. Yeah, I can do that. That's good. Yeah, I mean, billion's a lot more. So trillion would be another 1,000 times that. So whatever you just said, 10,000.
30,000.
Heyo.
Quick math.
What?
finished, what number was that with the
36.
36? 37 has this giant list.
Oh, God, I hate looking at it.
Um,
Me too.
Look, I think of all the stuff I got to teach you in a single year, and then I look at your textbook, and like the reason that we get like a debate day and like some time to talk about the previous tests and like that one long lecture on the tragedy of the commons or like
Mushroom day.
yeah, mushroom talk. The reason that we can fit all that in is because your book just took like 10 days of lecture and made it into one study goal. That's like irreplaceable. Your book is so accurate and on point. You have a humongous list of things that you theoretically written down. If you did your job, the organic components, the organic compounds, the POPs, the infection, heavy metals, toxic pathways, the hormonally active ingredients, the radiation, thermal pollution, particulate pollution, EMF, noise, all that stuff. If you don't write them down, that's fine. It's your life. I'm happy for you. You're going to be great people either way. If you did write them down, that's like some solid notes. Your book is excellent. There's just a couple of things that I wanted to add. Just a couple. One of them that your book did not include
Light pollution.
is light pollution. Check this out. I believe that took $140,000 and 12 years of data to make. I got it for free out of National Geographic. This is a composite map of some like decade worth of satellite pictures that show the Earth at night with no clouds. So they'll like have a picture of like Santa Barbara County with no clouds one night, and they trim around Santa Barbara County, and then they stitch that together with a photograph of Ventura County last year with no clouds, and then like 5 years from now they'll get a picture of like Kern County with no clouds, and some places have a lot of clouds like the Himalaya, and so it takes a long time to find cloudless images and then stitch them all together, and then adjust the edges so it looks like an accurate projection. But check it out. From where you sit, all you see is the lights. So the first easy interpretation of this photograph is like, oh my God, Japan has a lot of lights, and like England has a lot of lights, and like New York, and hey, that's where Mexico City is. Weird. Obviously, you can see where the lights are, you can see where global development is focused, you can see another north versus south line. But the next time that you walk by this poster, if you get really close, you might notice that the lights are color-coded. If you look closely, there's some blue lights, some yellow lights, and some red lights.
There's a bunch in Russia.
Russia has a lot of red lights because that's where they burn off a whole bunch of natural gas. That's the extraction of petroleum. Have you all driven by that fireball of death between Rincon and Little Rincon, I think? That one big like chimney with the big, okay, that's burning off natural gas, like all those red flames. And then the blue is really tough to see unless you look at Japan. Nighttime fishing.
Blue is for nighttime fishing.
Yeah.
Why is that important enough to warrant a color?
Well, I mean, that's debatable, but whoever made this map thought that's an interesting thing to put on a map is where do we fish at night? And we fish a lot in the Pacific Islands and a lot in Japan. Japan has the world's largest fishing fleet. Also, there's yellow lights, which are forest fires. And I'll point out that most of those are in the southern hemisphere, by the way. When you, yeah,
I can't really notice in here, but what color are the lights that are like like on the east coast.
That's all the night lights, that's all white light.
Okay.
So the white light is just plain old urban lighting, it's just city light. If you Google light pollution, what you're gonna hear is a bunch of like bearded hippies like me that complain about you can't see the stars at night. I'm sure that you've heard some bearded hippie like me complain they can't see the stars at night. Raise your hand if you've heard some bearded hippie complain they can't see the stars at night. Okay. If you ever want to have the best star talk in North America, I can tell you where to go.
Montana.
Say what?
Montana.
No, not the best view of the stars, but the best naturalist guided lay on your back for an hour and a half and I'll tell you stories about constellations. I know the guy.
Your backyard.
He also has a hell of a beard. His beard's a little bit nicer than mine.
Oh.
And he plays the guitar. He plays the guitar and he's super handsome.
What's his name?
His name is Eric.
Eric's.
I thought he said Arabs.
Eric's.
That would be sick. Like, what? That would be sick.
You know, a little song, dude looks like a lady. But light pollution has 3 big impacts on wildlife that I need you to know. So I told you to leave a space to add light pollution. The 3 ecological impacts are, number 1, it affects the migration of birds. Birds either look for like glittering lakes in the moonlight, or they look for the reflection of snow to find mountains, or they try to follow the path of the moon through the night to travel from east to west or whatever. And a lot of migratory birds get really, really confused by cities. We know that cities are a tax along migratory routes. An unfortunate consequence, please look up, of our development is we really like to live where the birds fly. So that's called the Atlantic Flyway. That's the Pacific Flyway. This is the Western European Flyway. And this is the Asian Flyway. These are like major migratory paths. Of the big tracks that birds used to fly south to north, we've put lights on 4 of the 6. Like a lot of lights. And so we know that it affects migration of birds. Problem number 2, our habit of making lights has basically ruined the conditions for nocturnal animals. Globally, we're losing nocturnal animals because they can't find enough darkness.
Oh.
Raise your hand if you've been for like a nature walk, like outdoors away from humans at night before. Like long walk, hours?
Like an hour and a half.
Yeah. If you've been like out and about in the dark in the wilderness,
Kind of get
For like hours, that was
um, if you've been out and about in the dark in the wilderness, shut up. Go back to your seat, Chloe. You had a chance, sorry bro. Sorry, out. I just remembered, I don't have to put up with this, you don't even sit there. I don't care, there's nothing to see you later. Oh. If you walk around in the dark in the wilderness, maybe you've noticed that it's not really that dark. If you're out on a full moon, it's like you could read a book by that. You know, nocturnal animals aren't really out at night. Nocturnal animals are out at the dark part of the night. Like owls can only hunt after the full moon sets or before the full moon rises or whatever. When it's a full moon or a really bright moon, all the nocturnal animals stay in because the mouse sees them coming. And so when we add lights at night, we just exclude nocturnal animals. And if you look at that map, that's a lot of places where you can't have nocturnal animals. Problem number 3, the sea turtles get hit by cars on the freeway.
What?
Yeah. sea turtles get run over by cars, it's real.
See, why are sea turtles on the freeway?
Because they want to be.
Because when a sea turtle hatches, because it, when a sea turtle hatches, how do they know where the ocean is? They're like break out of their egg and they're like in the sand, and they're like,
Light shines on the ocean.
whoop, and they poke out of the sand, and like, how would they know where to go?
The light shines off the ocean.
They're drawn to the glittery lights on the ocean, which aren't nearly glittery enough if you've got Miami over there. So they're like, glitter, and they like, they get hit by cars. It's not like, I'm glad we can laugh. But like, night lights are like a really big deal for sea turtles. And this just illustrates there's a lot of weird things that we overlook about darkness and night light. But light pollution's a big deal. You've got this gigantic list. I refuse to go over all of them, but does anybody have like something that they would like me to help with in that list of pollutions? Yeah?
For electromagnetic fields, it said it was like like controversial. Like, is it not like completely backed up?
Yeah, so we know that extreme electromagnetic fields can really mess you up. But human exposure to EMFs is usually really subtle. Like day to day, the EMFs that you have in your environment are almost nothing. There's not a lot of EMFs in our daily lives, and so they're not really relevant exposures. The theoretical problem is not actually a common problem. One thing I'd like to point out, since nobody's asking, hormonally active agents are not themselves hormones. Hormonally active agents act like a hormone. How many of you have heard that, like, if you drink like a lot of soy milk, you get boobies?
Oh, I
Did you drink a lot of soy milk?
Like, no, I would never leave the house if I had boobies. I think it's called phytoestrogen. It's like a compound that's found in soy that just happens to look like the chemical has a shape that looks pretty close to estrogen. So when you have a lot of that in your bloodstream, your body's like, huh, estrogen, huh? And it'll like supposedly give you a slight feminization effect. The point I'm trying to make is not the story of how that soy milk thing works, but I do want to clarify that hormonally active agents are not usually straight up hormones. There's stuff that acts like a hormone. So you can have two separate problems in wastewater. You can have stuff that's hormonally active, and then if you have a big city with modern medicine, you can also have straight up hormones. Like my wife had cancer that responded to estrogen, so she's in like fake menopause, so she has to take hormones every day. And so our wastewater has straight up hormones in it from hormone therapy, which a lot of humans take. And then separate from hormone therapy, there's a whole bunch of random products in our environment that work like hormones, but they're actually. Yeah.
About nuclear radiation, is the only thing that we need to know that exposure to it is health problems? Because it didn't have any other
Yeah.
information.
One thing I would probably add is that more exposure raises the odds of health problems. So I think, how about this? Exposure is proportional to the risk of health problems. So more exposure raises the risk of health problems. And then we will talk a lot more about radiation and energy. We'll talk about nuclear energy.
But like, it's not needed for this specific
Yeah,
chart.
yeah. Anybody else? Okay. Let's do a little bit of math. I'd like to do study number 38. If you're really good at math and you already saw this and it's really easy, I apologize, but some kids are not really good at math.
Okay, so. A little better for the rest.
I don't know about you, but I'm not.
You sit next to Abe's name.
Isn't it better that we answered 5 questions and they're gonna get an A?
If you have a multicolored pen, this might help you.
I have a 94.
I have a single purple pen.
If you have a single pen, that's okay. I want to do my demo with a single utensil, and I'll give you a way to cheat if you have a single utensil. Let's get some basics first. 3%. We'll start with the basic. Write this as a decimal.
0.03.
Fine. And write this as a fraction.
3 over 100.
And what does percent mean?
Per 100.
Per 100, or over 100, or out of 100? Cent, like a century. So that just means of these over 100. Coincidentally, it used to look like that. And I think somewhere in the typewriter era, the percent symbol was invented.
Thank God. That's horrible.
0 per 100. Now, when I say 3.3 parts per million, all that is like parts per 100. That's 3.3, but instead of over 100, it's over a million. And if you're writing with a single utensil, write that again with the 3.3 way on the right and the 1 million kind of spread out. If you're writing with a single utensil. This is going to become important later. If I can translate 3.3 over a million into something over 100, then I can also translate that thing over 100 into a percent, right? Because over 100 is the same as the percent. Do we agree with that? So if I want to go from 3.3 parts per million into percent, I'm going to use this process every time. First, write it in parts per million. Then, write it again. Then write the per 100, then write the percentage symbol. And now, I'm going to move some decimals. And if I move the decimals on the top and the bottom, nothing changes. So I can go 1, 2, 3, 4 shifts to the left, and that would give me 100. So I'm going to take this decimal and I'm going to move it 4 times to the left. 1, 2, 3, 4.
Nice.
And I'm going to fill in those little troughs with zeros. That gave me 3 zeros and a 33. And based on this, I can just take those same numbers and make it a really tiny percentage. That's such a small number. That's why we use parts per million. Because it's just like easier than writing all those zeros. Maybe you've heard that scientists are lazy, they hate drawing zeros, so they invent units just to get rid of all the zeros. So if I have 24.5 parts per billion, and I want to get to percent, I'm going to do this exact same setup, but now I'm just saying billion. So 24.5 over more zeros. I'm going to write that exact same thing, but spaced out more. Exact same thing, and I'm going to write the over 100, and then I'm going to write blank space for the percent. Same procedure. We'll move this decimal 1, 2, 3, 4, 5, 6, 7 times to make it 100. And I said 7, right? 7. So we go 1, 2, 3, 4, 5, 6, 7. There's the decimal. Fill in those troughs with zeros. And look, now I've made it into hundreds. That was 5 zeros. That's a really small number, but we got it into percentage form. Raise your hand if you're a math dork.
Sadie.
Maybe 5 math dorks. If you're a math dork, I'm going to give you this explanation. But for everybody who's not a math dork, I'll just give you like a really simple shortcut. If you're not a math dork,
Sadie, no one asked. For
milligram per kilogram is the exact same thing as parts per million. So the last one, you just solve the exact same as the parts per million one. And if you're a math dork, milligram equals 1,000th of a gram, and kilogram equals 1,000 grams. So milligram over kilogram is 0.001 over 1,000 is 1 over a million. Math dorks unite. Everybody else, hey, parts per million, same thing. Okay.
I don't think you need to be a math dork to get that.
You underestimate yourself again. We can talk more math if you want. Otherwise, I want to do our last study goal of assignment 5.2, which is conveniently our warm-up today. Would somebody please explain to me what this means? Yeah.
At some point, a dosage is going to be, of anything is going to be toxic because of the threshold effects, and with the same logic, at some point it's not going to be toxic because there's not enough.
Yeah. One way that you can say this, quiet please, is a substance at a certain dosage can be toxic, and that exact same substance at a low enough dosage is not relevant. So if you'd like to go home today, smoke one cigarette.
Only one?
One only. And that was the only cigarette of your entire long life. You could enjoy one cigarette. You can flick the butt at your little sister. You can be done with cigarettes forever, and I can give you a personal guarantee that you're not going to die of cancer from smoking that one cigarette. Or, better yet, we'd all like to try heroin, I'm sure. You could go pick up a free syringe, cook up a little batch of, you heat up heroin on a spoon, right?
Yes.
Yeah, you can heat up your heroin on a spoon.
Ever seen Pulp Fiction?
And then, as long as you cut your dosage really, 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 really low, like 1/1,000,000th of that spoon, into otherwise sterile saline solution, you could shoot that. I guarantee you'll be fine.
What's the point?
That all the things that we know to be toxic, all the things that we know to be toxic are not absolutely toxic. That for the deadliest thing on our planet, there is a low enough dose that it doesn't matter. And then there's a dose where it starts to have an effect on you. And then there's a dose where it starts to be really bad for you. And then there's a dose that starts to kill you. For every substance, good or bad, you can overdose on plain old, clean, bottled drinking water.
How much would it take to kill yourself?
You can find the number because some poor lady, single mom with 3 jobs, entered a contest at a radio station in California in the year 2007.
Yeah, die.
I'm glad we can laugh, but homegirl was like, I'm broke as F. I got a kid at home. There's no way I can buy him a Wii video game, what do you call it, console? She couldn't afford to buy him a Wii, and then she's listening to the radio between her second and third job of the day. And she's like, wait, they have a contest on Saturday? She got the day off work from one of her jobs so that she could go. In the beginning of the contest, they ask a bunch of like high school and college gamer bros, plus her, why do you think you're gonna win? And one of them's like, oh dude, I got like 3 Wii's, but I gotta get one in my bathroom so I don't have to interrupt my play, so like, I think I'm gonna win because I really want this thing. And somebody else is like, I'm practicing, I drink a bunch of water because I really want to play more video games. And then they ask the lady, like, lady, why are you gonna win? And she's like, because I love my son so much. And he's been wanting to do this, he's been wanting a Wii and he keeps asking me and I can't afford it. But I'm a nurse and I have to stay on my feet for like 10-hour stretches without peeing. So I'm pretty sure that I have like the strongest bladder out of everybody here. And I'm just gonna keep looking at this picture I brought of my son.
Oh my god. Oh.
I'm not laughing, you are.
Oh, baby.
And they gave each of them like a little 8-ounce bottle of water every 15 minutes over the course of like a Saturday morning broadcast. And by hour 2, like half the bros had dropped out, and by hour 3, almost everybody was gone. And by hour, I don't know, you can Google this, I forget. By hour 5 or something, it was the lady and one other dude. And the radio host was like, all right, you guys, are you ready for your last bottle? KJE, whatever. And the guy was like, I don't think I can do it. I'm about to pee my pants. Oh my God, I'm going to pee my pants. And I'm like, so are you bowing out? And the guy's like, I don't know. He starts like squirming. And I'm like, lady, are you doing all right? Hello? Excuse me, ma'am? She died.
So this one
Are you
gets
laughing?
weird.
You can drown from drinking water.
You essentially drown. So I don't know if you all know this, but like to communicate between your nerve cells, there's like something about ion exchange. The sodium potassium pump, is that how nerves communicate? Sodium potassium pump? So like the sodium potassium pump depends on like positive and negative charges that dissolve in water. And if you have like too much water and the polarity of water and the amount of sodium potassium in your body is not enough, and so you're like, your nerves stop communicating and your heart stops.
Die from.
Yeah, Yeah, so the poor lady died.
Did the radio station get in trouble?
I think that it did, but it took a long time. Yeah.
I hope the kid got some
Yeah, like,
A weed?
here's a win, a wee kid.
money or
instead.
something for it.
Score. I don't know.
Like someone. I hope the kid sues.
Okay, I will accept responsibility for this. You can blame me, but the level of morbidity in this conversation is really reaching nuclear levels, so I need to shift gears.
Can't play Mario Kart on my phone. That's alright.
My God.
Let this be a safe space for all the bad jokes, right?
I got so
But let's see if you can all remember something. As long as you live, whenever anybody says anything is toxic, you can tell them that doesn't matter. No. The perfect example is
Oh, here we go.
pure drinking water is toxic. We don't avoid that. Everybody knows the dosage issue when you're talking like how many French fries or how much salt to put on your mashed potatoes.
So much.
But we're bordering with pet peeves here that are actually destructive to our society and our economy. Think of how many times you've heard somebody say, I don't blank because it's toxic. Like that's a stupid phrase every time you've heard it. Every single time you've heard that, the person was saying something stupid. People are like, oh, I don't drink out of plastic water bottles because it's toxic. And the underlying science is that plastic supposedly leaches toxins into your water. And the punchline is, that's true. And the scientifically literate thing that matters is, you'd have to live 28,000 years to reach a level that matters of those toxins. You could drink all your water out of plastic containers. And yes, that would add toxins to your diet. And the amount is utterly irrelevant. People are like, no. I won't buy tomatoes from Safeway because they grow those with pesticides. And I heard that you can still test for the presence of pesticide in those tomatoes.
Oh my God.
And the answer is yes, there is pesticide in your tomatoes. The amount is completely irrelevant. People are like, I'll never use Roundup on my lawn because that puts Roundup into my children. I'm like, well, how much? I don't, by the way, I don't argue that everything is safe or that the numbers don't matter. It's just we don't have that part of the conversation ever. Everybody's like, oh, I'm going to boycott Campbell's soup because the cans are lined with PBA, polybisphenol A. And the answer is, yes they are. And you would have to eat 700 cans a day for that to matter.
Or
So if you don't, stop talking about the toxicity. People are like, no, I won't use that lipstick because it has some like toxin in it. You're like, how much lipstick are you eating? Yeah, you have to do the math. Like I just, people are like, no, I'm going to take a shortcut. That's toxic. And if we're going to get into shortcuts, don't drink water. That's toxic. If you keep your eyes open, we in the developed world live our whole life. We make these decisions 100 times a day about yes, no, toxic, not toxic. And if you don't discuss dosage, you're just babbling. Liam, will you kill the screen, please?
Yep.